Is that serious? Or it's not April 1st, is it?
No,
That was April 1st.
That was 2 days ago.
April 30th, that's my mom's birthday.
Yeah.
I think she's on a plane going to Las Vegas right now.
Why?
She likes to gamble.
Yeah, your family lives in Vegas.
Well, a lot of older people, they like to go to Vegas. It's good stuff, right?
What are you doing in Vegas?
Gamble!
Oh, dude, they have prostitution here too.
So you're saying my mom went to Vegas?
No, I'm just saying. They haven't.
What is my dad gonna do?
Enjoy himself. I was gonna say.
Oh, you better watch yourself.
Let's not talk about this.
Are we really doing Austin? Are you crazy? Suppose you play a game in which you make a bet, you draw a card from including the two jokers. If you pull out a joker, okay, so what's the probability of pulling out a joker? 2 out of 54. What's going to happen then? You keep your bet, you win $5. If you draw a face card, now what's the probability of pulling out a face card? There's how many face cards in the deck? 12, right? So 12 out of 54. You win, where does it say that? $2. If you draw any other card, isn't that 40 out of 54?
Yeah.
And you know how you can check your answers? Your probabilities got to add up to 1. If your probabilities don't add up to 1, you did something wrong. What happens? You lose your bet. What is the bet? $1. So you lose $1. Come on, that's it. That's expected value already. Where did we go wrong? How can anyone go wrong with that problem? No, you mean arithmetic. No, algebra and arithmetic are two different things. Okay, a box contains 3 red balls and 2 green balls. 2 balls are randomly chosen. If both are green, okay, we need to compute the probability that you get 2 green balls. Now, you want to think about it doing 1 at a time or 2 at once? Okay, wrong answer, but that's if you look at it that way. So what's the denominator going to be if you randomly choose 2 balls? I choose 2. Now there's 2 green balls in there. How many ways can you select 2 of them? 2 choose 2. That's the probability of getting 2 green balls. I'd rather do it this way. What about green on the first, green on the second? What's the probability of pulling out a green ball on the first draw? 2 fifths and then? And is that the only way you can get 2 greens? Green on the first,
Yes.
green on the second? Yeah. So I'd rather do it that way because like once you write it like this, then you have to write the numbers out and then let the canceling begin. But then if you do it this way, you can let the canceling begin from the beginning. Daga daga 2, 1/10. The probability of getting 2 green balls is 1/10. What happens when you do that? You win $2. If just one of them is green, okay, what's the probability of just getting 1 green ball? So green on the first, red on the second. What's the probability of that happening? 2 fifths, and then now red. Huh? 3/4. But is that the only order you can get 1 green and 1 red? No, so you gotta multiply by 2. See, the only thing is, when you pull out the balls 1 at a time, then you gotta multiply by the number of orders. If you did it this way, like you want 1 green ball and 1 red ball, then you don't have to worry about any order. But I don't really care which way you do it. I want to see the correct probability there. So what would this be? 3 fifths? Did I do that correctly? And what happens when you get 2 green, 1 green? You win $1. Otherwise, now what is otherwise? Maybe you should write this as 6/10. This is the probability of getting 2 greens. That's the probability of getting 1 green. So what's the probability of getting no greens?
3.
Yeah, because they all got to add up to 1, so it's 3/10. And what happens then? You lose $1. That's your expected value. Write that down on your paper. You get 3 out of 4. Actually, it's going to be worth 6 points on the test. So you write that down. You get 5 points. You want the last point to compute it. Number 3, a lottery has one $1,000 prize. What is the expected value of the buy? What is the 2,000 ticket with 100 each? Okay, so what's the probability of getting the grand prize?
Una
1 out of 2,000. Now, how much are you gonna win if you get the grand prize? Be careful. $999. We talked about this yesterday. How come it's not 1,000?
Because you lose the game.
Because you paid $1 for the ticket, that's why. So you really only won $999. You guys understand that? You said that yesterday. I don't know, I'm doing this on the board. What's the probability of getting second prize? 5 over 2,000. How much are you gonna win? $99. What's the probability of getting third prize? 20 out of 2,000. And how much are you gonna win? $9. And what's the probability of being a loser? Well, just add up these probabilities and subtract it from 1. So what is that gonna be? 26, so 1974. Is that correct? 1974 over 2,000, and what happens? You lose your $1. And there you go. Tell me what happened with that one. How come you guys write it on the board? I don't see any scribbling. Is this just to pass the time? Is that all this is? In the carnival game Chuck the Luck, you pick a number from 1 to 6 and roll 3 dice in succession. If your number comes up 3 times, you win $3. If your number comes up twice, you win $2. If it comes up once, you win $1. Otherwise, you lose $1. What is your expected value? Okay, what number you want to pick?
3.
Okay, so what's the probability of getting a 3, a 3, and a 3? 1 6 times 1 6 times 1 6. 1 out of 216. Everybody agree? And what's going to happen? You win $3. Okay, now what's the probability of rolling 2 3s? See, but the problem is there's an order to it. You can get a 3, and then not a 3. What's the probability of this happening? 1 6 times 1 6 times 5 6. But is that the only order you can get 2 3s? How many different orders are there here? 3, so you gotta multiply by 3, so that's 15 over 216. Is that the problem? What happens? You win $2. What's the probability of rolling only 1 3? So here, do a specific case. 3, not 3, not 3. What's the probability of that happening? 1 6 times 5 6 times 5 6. But how many different orders? 3. So what is that? 75 over 260? It's not in your head? You win $1. Otherwise, now, what do you want to do? You want to actually compute the other one, or you want to just add those 3 up and subtract it from 1? You know what I do? I would rather compute it and then double check to make sure they add up to 1. So what's the probability of getting not a 3, not a 3, boy, and not a 3? 5 6 times 5 6 times 5 6. And that's the only order, right? So 125 over 216. Do all of the probabilities add up to 1? Yes, so you know you're correct. And what happens? You lose $1. And there's your expected value right there. So what are you telling me? Are you telling me you guys have difficulties with the probability part? Okay, pull up period 3 on me. Just stare straight ahead. Just like they do. When I call their name, they pretend they don't hear it. Number 5, at many airports, a person can pay only $1. You guys ever saw these life insurance machines at the airport? I think they might have been outlawed there, but when I was younger, they used to have a lot of these machines there. So you can pay $1 for a $100,000 life insurance policy covering the duration of the flight. Suppose that past records indicate 0.45 deaths per million passengers. How much money can a company expect to gain on one policy? So what's the probability of death? This is a job. You ever heard of actuary? You ever heard of actuary?
That's what Mr. Chaplin Leatherman wants me.
Really?
Yeah.
It's like you study statistics so that you can determine what the premiums are for insurance and things like that. It's an actual job, you know. So anyway, what's the probability of death there? What does it say? 0.45 per million, which is 10 to the 6th power.
Is that true?
Huh?
That's true.
Well, I don't know. I got this out of a book, but this was like 20 years ago, so I'm sure it changed by then, right? By now. Okay, and what happens? What happens if there's death? but you have to pay $1, remember? How much are you gonna get? Well, are we gonna do this for the company or the passenger? Are we gonna compute the expected value for the company or for the passenger? Okay, for the company, so if there is a debt, the company has to pay out $100,000, but the person paid $1, so how much did the company lose? 99,999, is that right? What's the probability, if this is the probability of death, what's the probability of not death?
0.55.
1 minus. What? What? Say that again? I thought I heard something bad. And then what happens? Yeah, you keep the $1. There you go. That's it. That's the company's expected value. What does it come out? I'm just interested. What's the answer?
95.
So it comes out to 95, so 0.09, no, what am I talking? Yeah, 0.0, no, 0.955. So the company can expect to make 95.5 cents on every policy. So if you put these machines across airports across the whole United States or even the world, so if 1 billion people decided I want to pay the $1, then the company will probably make $955 million.
But what if a bunch of people are on the same plane and it crashes?
Yeah, but that's see, you're looking over the long term. Yeah, that definitely could happen, right? Number 6. From a standard deck of cards, 2 cards are randomly drawn. If they form a pair, you win $16. Otherwise, you lose $1. What is your expected value? So we need to compute the probability that you get a pair. Come on, we know how to do this. How do you want to do it? 1 at a time or 2 at once? 1 at a time, so specific case. Okay, 2 jacks then. What's the probability of pulling out a jack on the first card? You gotta be joking me. 4 out of 52, and then jack on the second card. 3 out of 51. So this is the probability of just getting 2 jacks. What about 2 of anything? Times 13. Let the canceling begin. 4 times 13 cancels to 52. 3 goes into 51 17 times. 117. So the probability of getting a pair is 117. And what happens? You win $16. Otherwise, now what's the probability of not getting a pair then?
1 minus.
Yeah, so subtract that from 1, you get 16 cents. What happens? You lose $1. Now notice what happens. What happens when you add these numbers up?
0.
You get 0. If the expected value is 0, we say that this game is
Fair.
How do you know?
It isn't on the bottom.
Oh yeah. I thought you were smart for a change. I guess not. Number 7. 4 fair coins are tossed. This is just like the quiz. If 3 or 4 heads show, you win $3. Otherwise, you lose $1. So we need to compute the probability of getting 3 or 4 heads. Okay, so shall we do the binomial probability thing then?
Yeah.
Okay, so what? I'm going to toss the coin 4 times. What's the probability of getting 3 heads? 3 successes. 4 choose 3. 1/2 to the 3. 1/2 to the 1, right? Because tossing a tail is a failure. What's the probability of getting 4 heads? 4 choose 4. 1/2 to the 4. 1/2 to the 0. So let's compute this. 4 choose 3 is the same thing as 4 choose 1, which is 4. And 2 to the 4th is 16. So this is 4 over 16. Plus this is 1. And that's all 1. So that's 1/16. So 5/16. Did I do that correctly? See, if you don't compute the probability correctly, come on. You win $3. Otherwise, what's otherwise? Yeah, so if this is the probability of getting 3 or 4 heads, you win $3. So what's the probability of not getting 3 or 4 heads? 11 out of 16 because you just subtract that from 1. And it says you lose $1. Now, probably on the test, see, this is kind of simplified. It's going to be more complicated than that. It's going to be like you toss a coin, a weighted coin, 4 times. If 1 head shows, this. If 2 heads shows, this. If 3 heads, and so forth. I'm just going to have more cases though. Huh? Okay, so I did the whole thing for you.
The problem is your homework.
Okay, now tonight we're only gonna do one practice test, so let me pick the better one. Should we do probability 7 or 8? Let me look.
Holy
Which one is better? They're both. Both look pretty juicy.
Why don't you pick problems?
7 looks really scary.
Pick the good problems from each.
Oh my god, 13. It's stressing me out. It's only one more. Yeah. Just do a makeup.
Replaced. They're each draw, and then I see the birthday problem there, which some of you need practice on. Because that the birthday problem was definitely on the test, except there's a lemony twist to it. Okay, we're gonna do probability 8.
Okay.
Wait. Okay, we're gonna do probability 8
Numbers.
and number 12 from probability 7. Because on probability 8, I don't see a conditional probability problem there. No, I do. Never mind. We're just gonna do probability 8. Okay, so no other questions then. We're done. So we'll discuss. Oh, look, got the married couple. Oh, got the prom problem. Remember the prom problem? Remember the prom problem from back?
The love seats?
The love seat, the love benches. Have we forgotten love benches?
The factorial, the thing minus 1 factorial, right?
N minus 1 quantity factorial. Okay, we're done. Use your time wisely. You got 13 minutes remaining.
Sorry, did I drink water?
Yep.
Mr. Park, so which one is
You got
last?
that game too.
No.
Up to 8.
Up to 8, okay, this one? Okay.
Well, if you're gonna take the test today, then you only have to do up to 6.
And the